Hello friends, welcome back to another video tutorial. Today I'm going to share some of the basic information about how silver nanoparticles kill pathogens. Okay, so basically the silver particles are used for wide range of applications including healthcare products, textile, cosmetics due to their strong antibacterial activity. So other than this antibacterial activity, the silver nanoparticles have good chemical stability, good catalytic activity and good optical properties. So because these all properties of silver nanoparticles are strongly influenced by their size and the shapes. Okay, so because similar to other metallic nanoparticle, this silver nanoparticle also we can synthesize from in different size and shapes from our laboratory by various synthesis approaches. Like there are different synthesis methods are there, like physical and chemical synthesis methods. So some of the one is a physical method, that is evaporation, condensation and laser ablation methods are most important physical approaches. Another is chemical methods, so which include chemical reduction methods. So in this we can use any organic or inorganic reducing agents. So and with suitable capping agent for the better stability. And another synthesis approaches are microemulsion, UV-initiated photoreduction method, wave assisted synthesis, like different approaches are there. Okay, so based on that we can synthesize different shapes of silver nanoparticle, like a rod, cubes or pyramids or triangle, like different nanoparticle we can synthesize. Okay, so next is the properties of silver nanoparticles. The first one is the optical properties. So the optical properties similar to the metal means other metal nanoparticle like gold nanoparticle, it have SPR effect, that is surface plasmon resonance. That is when silver nanoparticles are exposed to specific wavelength of light, then the oscillating electromagnetic field of the light which induce a collective coherent oscillation of the free electron in the particle surface, so which cause some charge separation with respect to the ionic lattice, so that will create some dipole oscillation along the direction of the electric field of the light. So when this amplitude of this oscillation reaches the maximum at a specific frequency, so that we call as the surface plasmon resonance. Okay, so other optical properties, like it have size and shape dependent absorption and scattering properties. So these are the optical properties of the silver nanoparticles. Other is the antibacterial effect. So because of the antibacterial effect of silver nanoparticle, which have been used to control bacterial growth in variety of applications, including healthcare applications like dental work, surgery applications, wound and burn treatments and biomedical devices, like different applications are there. So in this section I'm going to discuss a detail about how silver nanoparticles kill the bacteria. Okay, that is antibacterial mechanism of silver nanoparticle. Okay, so there is an exact effect of silver nanoparticle on bacteria is still undefined. So even though there are two antibacterial mechanisms which are widely accepted, that is one is contact killing, another is ion mediated killing. Okay, so first one is contact killing or direct means killing. So in this when the silver nanoparticle interacted with this bacteria or microbes, then this silver nanoparticle can anchor to the bacteria cell wall, and then that leads to the silver nanoparticle interacted with the membrane, means bacterial membrane, then it damages the membrane surfaces, and then it leads to some leakage of cellular components and further bacterial death. Okay, so there are many researchers reported that this kind of antibacterial effect of silver nanoparticle is more in gram-negative bacteria than gram-positive bacteria. Okay, so the reason is this gram and positive bacteria have cell wall thickness around 30 nanometer, but this gram-negative bacteria is have the cell wall thickness of 3 to 4 nanometer. Okay. Next is if you need to enhance the antibacterial effect of silver nanoparticle, we need to alter the surface charge of silver nanoparticle. Okay. Why? Because this cell wall of this bacteria is made up of means carboxyl, phosphate and amino groups. So because of that it have negative charge. So because of this negative charge there is a electrostatic attraction between this silver nanoparticle and the bacterial surface. So if the silver nanoparticle with more positive charge, it can bind easily. Okay, so likewise we can enhance the antibacterial effect. Okay, so in addition to that, once the silver nanoparticle enter into the bacterial cell wall and it enter into the cytoplasm, and it interacted with the different biomolecules and the cellular organs, and which leads to some production of reactive oxygen species like hydrogen peroxide, superoxide and singlet oxygen. So once the production of ROS is more, that leads to some unbalancing in between the ROS and the antioxidant. So that leads to some damages like lipid peroxidation, DNA damage. So likewise also this cell death is occur. Okay. So next is another one approach is the ion mediated means approaches, that is okay. So in this ion mediated approaches, this silver nanoparticle release Ag+ into bacteria. Okay, so that release of this ion is depend upon the size of the nanoparticle. That is, if size of the nanoparticle is very small, it have higher surface area. Okay, so it can release more ions. Okay, compared to the larger particle. So once this silver nanoparticle release the ions, it can interface with the sulfhydryl groups in the enzymes and proteins which is present in the cell wall. Okay, so it bind with this group so that it can bind to these proteins, and then this protein get deactivate. Okay, so then it enter into the cytoplasm, means into the cell, and then cause some oxidative stress. So this oxidative stress will lead more production of ROS, and then leads to cell death. Okay, so this is about the ion mediated antibacterial mechanism. Okay, so this is all about the how this silver nanoparticle kills the microbes. Okay, so next is the application part. So because of these unique properties like good antibacterial effect, unique optical properties, these silver nanoparticles are widely used in different applications like antibacterial, antiviral, antifungal. Okay, and we can use this silver nanoparticle in cosmetics, water treatment, textile application, biosensing. Yes, different applications are there. Okay, that's it. Okay, thank you for watching. If you like this tutorial, please share with your friends and contacts. Thank you.